Okay, so we're through with the generating function joy, all right? So sadness for some of you. But we're moving on to other pieces. Now, normally I guess I would go on with contagion, but I think I'm going to start talking about this line of work here, which is in centrality. Okay, so it sort of starts here actually, and it goes into structure detection. So I think these two will be good pieces. I'm going to archive this properly because this is a sortativity using kind of an initial way to do it. It's not, it was well cited, all this sort of stuff. But I'm going to kind of put that in a box, I think. It's all very nice, but it's the wrong way to go about it. This is a better way to look at those things. So, we've talked a lot about random networks, but you can start to add things like, well, I want correlations between nodes. I want all these sorts of things, right? So I want high-degree nodes to connect to high-degree nodes. Let's do that with some degree distribution. What does that make, right? So there are really hard problems in terms of constructing a network with a fixed degree distribution and a certain level of clustering. And everything else being random. That turned out to be a really hard problem, right? So you have this box with networks in it, random networks in it, but pulling out ones that match the real world are hard. And there are certain kinds of dials you might want to turn on the side of it that are just really, really hard to control, actually, right? You can't just say, I want this sort of network with these three characteristics. Pretty hard. So that's why it's always often better to have some model. Like the bipartite affiliation structures, that gave us a very sort of surprisingly realistic representation once we, conditioned it on saying, well, there are all these groups here and all these other groups and they're connected randomly. Anyway, so I'm going to abandon that. This is old work. It's well cited, generalized contagion. It connects disease spreading to social spreading. So it's very enjoyable. There's a lot of fun math in there, but I guess I'll downplay this. I'll come back to this a bit later on, but I think here, we're going to go here and then here. This is really about, this comes out of social contagion. Chaotic contagion is one of the weirdest things I've ever worked on. Anyway, so we might talk about that a little bit.